All right, so we are moving on to the next step of this, which is called linear programming. And basically, it's a process to help management in decision making. So we will have decision variables, we will have our objective function. That's going to be a maximum or a minimum sentence. We will have our problem constraints, and we will then graph, find our corner points. We will test those corner points in our objective function. That will then determine which one is, of course, the best solution. Because anytime we graph these linear programmings, we have multiple potential solutions along the lines or inside the shaded region. The goal is now to determine which one is going to be the best based on our objective function. First one says, manufacturing plant makes two types of inflatable boats, a 2-person boat and a 4-person boat. And as I do this, as I read this, I'm going to write my information here. So 2-person, 4-person. We have cutting and assembly. Each 2-person boat requires 0.9 hours from the cutting department and 0.8 hours from the assembly department. Each 4-person boat requires 1.8 hours from the cutting department and 1.2 hours from the assembly department. The maximum labor hours available per month in the cutting department. So here we have a max of cutting is 864 and assembly is 672, respectively. So the company makes a profit of $25 on each 2-person boat and $40 on each 4-person boat. So we're going to work through the entire process here. So A says identify the decision variables. Well, this is what they're making profit on. So we have two variables, X and Y, and they're going to represent our 2-person boat and our 4-person boat. So X is a 2-person boat. Y is my 4-person boat. Part B, I actually already did, where it said to put the data into a table. That's just because I default put any word problem like this into a table before I keep moving. C is write the objective function P. So P stands for profit. Our objective function is our profit. So profit equals, I make $25 on every X or 2-person boat that I sell, and $40 for every Y or 4-person boat. So our objective function is going to be an equals to equation where every problem constraint that we write is our inequalities. So for D, when it says write the problem constraints and non-negative constraints, so that just means all the inequalities that relate to this problem. So if I look across this first row here, I have 0.9x plus 1.8y, my maximum, so less than or equal to 864. Second row is 0.8x plus 1.2y less than or equal to 672. Lastly, we have x has to be greater than or equal to 0, and y has to be greater than or equal to 0 because we cannot have negative boats being sold. All right, so now we are at the stage just like before, where we're going to graph our feasible region. So I will use Desmos. Don't worry about this extra part here where it says like include the graph of the objective function. You don't need to worry about that. We just need to graph our feasible region. Let me get Desmos open here. Graphing calculator. All right, so 0.9x plus 1.8y less equal 864. 0.8x plus 1.2y less equal 672. X greater equals 0. Y greater equals 0. Oops. So I enter all of those first so that I can take them, take the first one, paste it, and copy all the constraints over in the curly brackets. So Control V, X greater equal 0, Y, greater equal 0. So I like to do that first so that I can then go back and then just change these to the line form so that I'll be able to find my corner points. If we click on our graph, so corner point 1, corner, there's that one, corner point 2. This one's going to be a corner point here, corner point 3. And then our origin is also a corner point. So when we have 4 lines, so 4 inequalities, 1, 2, 3, 4, 4 intersection points that we are going to have. Now, when we go to the next part here, do I really need to check 0, 0? No. Okay. When we go to check for our optimum solution, it makes no sense to plug in the corner point 0, 0. That means I'm selling no boats at all. I'm making no profit. So at that point, I'm not going to list in the next part that I'm going to do here. So I'm going to make a table, X, Y, and P with the points I do have aside from the origin. So that was 0 and 480, 480 and 240, and then 840 and 0. So again, I don't need to put the corner point of 0, 0 here because plugging into zeros for the P function is just going to give me 0. It's not going to give me the best profit that I can make. So now you just grab your calculator and we're going to plug the X and the Y into your objective function or your P function here, your profit function. So 25 times 0 is just 0. So all I need to do is take 40 times 480. So if I take 40 times 180, I'm going to get $19,200. That is the profit I would make from selling 480 4-person boats. Next one, I'm going to plug in 480 times 25, add that to 240 times 40, and that one is going to give me $21,600. And then the third point is plugging in 840 for X. So plug in 840 times 25, and you will get $21,000. Now, if your goal is working at this company and you're selling boats, you're going to want to make the most amount of profit. Well, which of those, the first, the second, or the third, is the largest profit? The second one, okay? So then that is our final answer or our optimum solution. So literally everything up until that last part, we've already done, okay? We've already turned the data into a table. We've turned it into inequalities. We've graphed it. We've found our corner points. The only extra step now is to create that objective function and plug it in to find our max or min profit, whatever it is we're looking for. All right. So this is the final solution. And that is going to be selling 480 two-person boats, 240 four-person boats to get a profit of $21,600. Yeah. That's how I got the 21,600.
Okay.
25 times 480 plus 240 times 40. Yeah, you made me double check my math, but yeah, that's how I got it. You're literally just plugging these into this guy over here. Yep. This one wants us to find both the minimum and the maximum P here. So our P function is 30x plus 10y, and we have 1, 2, 3, 4, 5 constraints. So 2x plus 2y greater than or equal to 4, 6x plus 4y less than or equal to 36, 2x plus y less than or equal to 10, and x and y are both greater than or equal to 0. So everything is already made for us here. I'm going to, whoa, move this over here. Okay, I'm going to try to put all of these in one. Just because the numbers don't seem too high, I should be able to count my points. 2x plus 2y greater or equal 4. And then I'm just going to put them all in here. So in brackets, 6x plus 4y less equal 36. Bracket, oops, not p. 2x plus y less equal 10. Am I typing? There we go. X greater equal 0, y greater equal 0. And it's going to look like there's nothing there because I'm very zoomed out. I'll need to zoom back in, and you'll be able to see it here. Okay, so I can see I'm counting by ones. So this point here is 2, 0. I'll pop that on the graph. I then have a 5, 0. I'll label that one. Next one I have here is at 0, 2. Going up, I have 0, 9. I want to label. And then there's one over here. Right here at, what is that? 3, 6. Nope. 2, 6. Comma 6. There it is. we had 5 lines, 5 corner points. I have all 5 listed there. So now I'm going to take all 5 of those, put them in a table, and plug them in for P. So let's see, I have X, Y, P, 0, 2, 0, 9. We had 2, 6, 5, 0, and 2, 0. It doesn't matter the order you put them in, just get them all on there. Okay, so remember P is 30X plus 10Y. So no X's, 2 Y's, 2 times 10, 20. No X's, 9 Y's, 9 times 10, 90. 30 times 2 is 60, plus another 60 is 120. Now we're plugging 5 in for X, so 5 times 30 is 150, and 2 times 30 is 60. That is my completed table. Okay, so we're looking for our smallest P and our largest P. What's the smallest P? 20. And which one was the largest? 150. So then this is my minimum. This is my maximum. So we'll try a few more here. A furniture company has 2 plants that produce the lumber used in manufacturing tables and chairs. Okay, so we have, let's see, we're making tables and chairs. And we have 2 plants, so plant A and plant B. In 1 day of operation, plant A can produce the lumber required to make 20 tables and 60 chairs. Plant B can produce the lumber required to manufacture 25 tables and 50 chairs. The company needs enough lumber to manufacture at least, so at least, I'm going to have to put it down here, 200 tables and 500 chairs. If it costs $1,000 to operate at plant A for a day and $900 to operate at plant B for a day, how many days should each plant be operated to produce a sufficient amount of lumber at a minimum cost? And then what is that minimum cost? All right, so as I'm reading that, it's asking me how many days. So X is the number of days at A, and Y is going to be the number of days at B. So my equations are going to be in vertical form this time. 20X, 25Y is going to get me that 200. And then 60X and 50Y is going to get me that 500. 20X plus 25Y, it says at least. That means at the lowest. Oops, wrong button. At the lowest means I need to be bigger than or equal to 200. And then 60X plus 50Y greater or equal 500. And then we always have X and Y greater than or equal to 0. We want a minimum cost. So I'm going to make minimum C, and my cost is it's 1,000 for every day at A, so 1,000X plus 900 at Y. Half. 20X, 25Y greater equal 200. 60X plus 50Y greater equals 0. X greater equals 0. Y greater equals 0. Oops. Hold on. Put that in the wrong spot. X greater equals 0. All right, so if I take the first one, copy it down. That's not right. That should be 500. There we go. Okay, copy this one. Control C, Control V. X greater equals 0. Y greater equals 0. Oh my goodness. Not 1, 0. Okay, so I can go back, make that an equals. Back, make that equals. All right. So this is an unbounded, but there's a corner. There's a corner. And there is a corner. I have all these extra blanks in here. So 0, 10, 5, 4, and 10, 0. And 5, 4. And then I'm going to do my C function, X, Y, and then C because I have cost. If I plug in time for Y, it's going to give me $9,000 for cost of that one. I plug in 10 for X, that's $10,000 there. Okay, it's gonna be 5,000 plus 3,600, 8,600. So we wanted the minimum cost. So here is our minimum cost. And that is going to be if I do 5 days at A and 4 days at B, is going to give me the least amount of cost, which is $8,600. Okay, so B says discuss the effect on the operating schedule and the minimum cost if the daily cost of operating plant A can be reduced to $600, but everything else remains the same. So I'm not changing anything up here. I'm not changing any of my initial constraints, but management is able to adjust the cost to produce at plant A from $1,000 down to $600. So my new cost is 600 at X, 900 at Y. And we still have those same corner points. We haven't changed those values of 0, 10, 10, 0, and 5, 4. So those haven't changed. So if this is the new scenario, 10 times 900 is still 9,000. 10 times 600 is 6,000. That's going to be 3,000 plus 3,600, 6,600. So now the lowest cost is 6,000, and I would do 10 days at A. And part C says discuss the effect on operating schedule and minimum cost. If I can reduce the operating plant B is reduced to 800, but everything going back to A stayed the same. So I'm now back to $1,000 for A, but instead of 900, it's now down to 800 for B. So 1,000 for X, and now 800 for Y. Oh, so done testing 0, 10, 10, 0, and 5, 4. So if I plug in 10 for Y, that's 8,000. 10 for X is 10,000. Okay, that's gonna be 5,000. 4 times 8, 3,200. 8,200 for the combination. And now my lowest is 10 days at 8. So you can see how adjusting the costs can determine where it's best to then do my production. A city council voted to conduct a study on inner city community problems using sociologists and research assistants from a nearby university. Allocation of time and cost per week are given in the following table. How many sociologists and how many research assistants? So right there, that already tells me what X and Y is. X is number of I'm spelling it wrong. Sociologists. And Y is the number of research assistants. Should be hired to minimize the cost and meet weekly labor hour requirements. What is the minimum weekly cost? Okay, so the cost is down here. I'll use that in a minute. Well, we're first going to create our inequalities. So X, X, Y, Y. 10X plus 30Y. I need to reach a minimum of 180. So greater than or equal to 180. 30X, 10Y, greater than or equal to 140. And X and Y are both greater than or equal to 0. Now, we want to eventually find the minimum weekly cost. So it is $500 for the sociologist, $300 for the research assistant. So cost equals 500X plus 300Y. Okay, so we've got what our variables stand for. These are our inequalities. This is our objective function. So next is to graph and find all the corner points. All right, 10X plus 30Y greater than or equal to 180. 30X plus 10Y greater than or equal to 140. X greater than or equal to 0. Y greater than or equal to 0. All right, so let's take the first one. Paste it down. Second one. Paste it in brackets. X greater equal 0. Y greater equal 0. Do I have an extra bracket somewhere? Yeah, okay. So that I can change these to equals. Okay, so it looks like I've got this one up here. I've got this one here. And then there's one over here. So graph, and my corner points are right there. So next up is to create my table with my X, my Y's, and my C that I'm trying to minimize. So it's usually minimize cost, maximize profit. That's what you're always doing. So X, Y, cost. It was 0, 14, 3, 5, and 18, 0. Okay, so no X's. 14 times 3, 4,200. 5, so is that 1,500 and another 1,500? So 3,000 for that. That's going to be, hold on. Yeah, 4,000 plus 5,000, 9,000. Plugging in 18 times 500 is going to be $9,000. So we want our minimum cost. So our point that gives us our minimum cost is 3,500. The minimum cost is $3,000. Real world meaning, what does that mean we've got? That is 3 X's. So 3 sociologists and 5 research assistants. And I will upload, I realized that I didn't have the completed PowerPoint on Blackboard, so I will upload this once we're done here. So I have one for you guys to do, and I'm having you do the entire process. This one is probably the most amount of points that we're going to do here. This, I mean, I could talk about it really quick. So heads up, work on 5.2 and 5.3 homework after we do the quick quiz. There is an exam 1 review that is posted. All of the answers are also posted on that as well. There may be one problem that's wrong. I think I have an announcement saved that like one of them is typed wrong or something. So I'll share that in a second. We will have class on Tuesday where we will cover 6.1 and like an example from 6.2. And then any questions you have as far as like what you look at the review guide. So anything from chapter 4 and 5, we can go over. And then I'll also show you on Tuesday how to actually access the exam, how to, if you're going to upload stuff or type a matrix in, whatever. We'll talk about all of that. And then next week, Thursday, we won't actually have class. And this isn't the actual due date. I'll adjust the due date when we get there. But Thursday, I will give you off as a work day to work on the test. But I always give like through the weekend and a little bit to do it. So we'll talk more about the test next week, but just kind of giving you the heads up there. So the quick check is the last problem that's on the bottom there. Now, I have it worth a lot of points here. And you can see my point breakdown on the bottom here. For 22 points. So I want you to show me every step along the way. First part is, tell me what your 2 variables represent. Write your inequalities. Write your objective function. Graph and show me all the corner points. Okay? Then you're going to make your table of all your corner points and your corresponding profits. Which point gives us the, sorry, that should say cost, not profit. Which one gives us the minimum cost? How many yards of each mix will the farmer be buying? And how much will the farmer then spend? So lots of pieces in there, corresponding costs. So just like before, you can do a combination of screenshots of Desmos, typed, handwritten, pictures, whatever you want. But I just want to see you work fully through the entire process. All and double check when you're done. Did I do every single one of these to make sure I get all my points? Question. Always. Always. Yeah. That is never not an option, meaning it always is an option.